Welcome to my channel, AI Basics with AK. Here we are for our next new episode, Numbers and Booleans. Let's dwell deep into it. So, let's click on the slides. Yep, it's loading. Yeah, I got a new template. I hope this is beautiful. You'll love it. So, yes, the episode 3, Numbers and Booleans. This is our agenda for today. Booleans, integers, floats, typecasting, arithmetic operators, and comparison operators. Let's start the Boolean slide. Booleans are nothing but true or false. This is highly useful when we start discussing about comparison operators. What are comparison operators? When you compare different set of variables. When you compare it, you will come to know whether this comparison is right or this comparison is wrong, right? So that's one of the most useful use case, and we combine this with several other control statements. You will see the beauty of it. But as of now, okay, think that, okay, there is some output that will throw as a true and some output throw as a false. How those true and false are stored? These are stored as Booleans. So quickly just run through these examples. Here, this I think you would be knowing about from our episode 2, where we have identify the variable type by using type function. So here we have defined something as a true, so it is throwing as an Boolean. Similarly, as a false, it throws an output like an Boolean. At a backend, true is stored as 1, whereas false is stored as 0. Makes sense, right? It's quite intuitive. So when we start adding like an arithmetic operations, like 1 plus 0, it gives an output 1. And 1 into 0, it gives an output as 0. This is also very beautiful piece. Here we are using AND and an OR. It's like an AND and an OR gate that we would have learned during our engineering days. So AND and OR gate is very simple. Here I'll just make it out. What is an AND gate? When you have two variables and there is an output. If it is in 1 and 1, the output is 1. If 1 and 0, the output is always 0. 0 and 1, output is 0. And 0 and 0, always 0. With respect to OR, the OR will be something like this. If either of them is 1 and 1, it is 1. 1 and 0, it is 1. 0 and 1, it is 1. And 0 and 0, it is 0. So here the variable 1 is 1 and 0. So since it's an AND operator, it gives false. Here it is an OR operator, it gives true. Very simple. This is the comparison operators where we are asking whether 3 is greater than 2. Right. So this is true. 3 is less than 2. Of course, it's false, right? So it gives an output false. It's very intuitive, right? It gives output as in very intuitive sense. So that's why Python or similar tools like that R is very beautiful. But yeah, Python is more OOPS, but R is not an object-oriented programming. Here we are combining both comparison operators with respect to the logical operators. 3 is greater than 2, which is true. 2 is less than variable 1. Variable 1 is 0 and false. So whether true and false, it is false. True or false, which is nothing but 1 or 0, which is nothing but true. The same, this one here, we have just elongated an example here to showcase how we can combine multiple things. Beautiful, isn't it? Let's jump into integers. Here, the integers, I think it's very common because we have seen in our previous slides from episode 1 and episode 2 and right now in episode 3, the previous examples also were like 1 and 0. These are all nothing but an integers. So at back end, you can think integers is like a number line. From like when we are kids, we used to draw some number line where 0 comes in between and say minus n, etc., and then minus 1, and then 1, 2, etc., and n, and it can go where n can be minus infinity and plus infinity. So this is like a number line, okay, where integer is only these numbers, whereas real numbers, if we know about it, it also falls between these things, which is nothing but real numbers. But moreover, integers are nothing but your absolute numbers. You can treat these integers as your absolute numbers. So this gives you a little bit intuition for you for these slides, because anything that is in between, it is not an integer, because that's a real number in programming that is called floats, which we'll see in our next slide. Here, when we are seeing these integers, here we have discussed variable 1. Yes, of course it is 100. Even minus 100, which we have discussed as a number line, of course it is an integer. Just this is a basic plus operations where it has also outputs like 2 integers. When we are adding it out, of course output will also be an integer. Most beauty is that if we think that, okay, let's print out something as commas. So when we print 1 million here, including comma, it gives a different output altogether as a list. So when you want to define something like a million kind of a thing, like you want to create a variable as a million using these operations, it will be treating as a list like 1, 0 and 0. Instead of that, to have this readability kind of a thing, Python has in a later versions, I think from 2.6 version, or I don't remember in exactly, maybe people can correct me. I assume it is from 2.6 version. They have introduced this readability for the people who want to write in this fashion as an underscore. Sorry for that line, but yeah, you can write something like 1 million as 1 underscore and like this underscore. So this instead of comma, here you can use an underscore, which nothing but it is a 1 million. The same thing we can see it in this example. Now you might be thinking, can I define something like this minus 1? Like, can I declare a variable is minus 1? Can we? I'm asking. Just pause for 1 minute and think, can we? No, we can't, because in our previous episode, we have learned that defining a variable can start with either with an underscore or a character. So the moment you put underscore, Python interprets that this is a variable. When it is a variable, if you want to assign variable as a variable, maybe this underscore 1, if you define it earlier as, say for example, as an integer 100, maybe this assignment might look right where you will assign variable to 100. But certainly variable 1 is not equal to 1 at this point of time, because underscore 1 is a variable. Here, so we can see the same thing here, where underscore 1 we have defined as 1 underscore 3 underscore 4. Just this is an example. Nobody will store this variable as 1 underscore 3 underscore 4. Only like a complicated, longer, elongate number if you want to save it out, especially for mathematical or statistical operations or advanced engineering operations. People use this kind of a notation, but on a normal, I have not seen in my work experience people representing a number in this fashion. But for this example, let's consider that, okay, 1 underscore 3 underscore 4, which is nothing but 134. So you are assigning that 134 to a variable minus 1, which is nothing but an integer variable. Hope this makes sense. So let's go to our next slide, which is nothing but floats. So we have seen Booleans, Booleans are nothing but binary kind of an operations, whether it is a true or a false, nothing but 1 or 0. Integers, we have expanded the timeline, like an timeline from instead of 1 and 0, we have increased it to minus infinity to plus infinity on a number line, where we have only an absolute numbers like 1, 2, 3, 4, like minus 1, minus 2, minus 3. Still, integers doesn't cater between the values between 1 and 2. Now there is something called floats. Floats can have the values between 1 and 2, like 1.1, 1.2, 1.0, everything. So everything like a real number, you think like real number is nothing but floats. So when we create a variable as phi dot, Python stores internally this variable as a float. So that's why it prints the variable instead of phi dot, it will print as phi dot 0, because internally it has typecasted itself as an float variable. Similarly, with the further examples where we have explicitly said that it is phi dot 0 as well as 0 phi dot, in all these cases, Python interpreted that it is a real number and we have to store it as a real number, which is nothing but in a programming context, it is a float variable. Anything that you add to a real number is of course a real number, right? So if we add a real number and add 1 to it, of course it becomes 6, which is nothing but a real number. So that's what it has stored as a real number, which is 6.0. The moment the decimal point comes, it is nothing but an float. If there is no point, you can think that it as an integer. Similarly, on the right hand side, these are further examples for a demonstration where you can say, for example, you have something like 5 into 10 to the power of 0. You can write this as a representation. It is one type of a representation where phi is 0, which is nothing but 5 into 10 to the power of 0, which is nothing but 5. If it is phi 1, which is nothing but 50, which is highly useful when you have a very large number, maybe 5 into 10 to the power of 7, you can just write it out as phi is 7, which is very easy in terms of writing. But in terms of storing, Python stores it at the same value. In the earlier sites, we have seen something as an underscore where it improves readability for the reader when he is reading that variable name. Now, just pause for a second this video and just think whether this representation makes sense or this representation makes sense. Of course, here it reads as 1.01, comma 1, maybe underscore, I'm just reading out as in comma, just for readability. Here, this is how it is. However, the moment there is an underscore and then a point, the Python interprets, okay, it's not something that I am aware of it. There is no integer after an underscore. So certainly it's a different representation. So here the Python fails to interpret what is this, and it throws an error, which we will see in our demo session. This is a very beautiful example when the pi is a very large number, right? We have a pi, which is March 14th is one of the pi day, which is called as a pi day, which is declared as a pi day. And here you can see it out 3.141 underscore 592 underscore 654, which is nothing but a pi value, which we are representing in 9 decimals. Now people can read it out in also in clear, like this improves readability kind of a thing. But out and out here, this slides represent as a float, which is nothing but a real number. We are trying to represent that real number in various fashions in here, like 1 in 10 to the power of 0, 1 in underscore, and then with the decimals. So here we have discussed 3 things. One is Booleans, integers, and floats. Now let's go something into typecasting, where we can convert one type of variable like a Boolean to an integer, maybe an integer to a float, okay? And a float to an integer as well, right? Everywhere that has to become possible. So the moment you convert true or a false into a float, of course, this gets stored as 1.0 and 0.0 instead of 1 and 0. If you put int, it becomes 1. Float, it becomes 1.0. Similarly, here, when we are defining a real number, which is 2.9, as an integer here, it cut downs whatever it is after decimal. Let me store that whatever before decimal it is, and then let me call that as an integer. So that's how the Python interprets and reads while typecasting it, where we are converting a float, which is 2.9, into an integer. So it stores whatever before the decimal it is. Now, here we are converting some integers into a Booleans. Boolean, anything an integer other than 0, it will be stored as a true. So that's how it is internally held stored, and it is very beautiful. The moment you say it is 0, it is false. Here we are adding an so something with a Boolean and float. Here it is stored as a float itself, because the float takes the preceding kind of a thing. Float, integer, and then Boolean. That's how you can always read it out, because real number, integer, and a binary kind of a thing. Here we are converting pi, so anything that is after the decimal, when we convert an integer, it will be stored as a 3. True, which is nothing but as a 1. So 3 plus 1 becomes 4. Here, I think I missed this example, excuse me for that. 5 e to the power of 1, which is nothing but 5, and 50, because 5 into 10 to the power of 1, which is 50, plus Boolean of 100, which is nothing but true, which is nothing but 1. So 50 plus 1, which is 51. Now, pi into true. True is nothing but 1, and pi is already declared as 3.141592. So the output is printed as 3.141592. Pi into false, which is nothing but false is nothing but 0, so it got printed as 0. So the typecasting in summary is nothing but you want to convert one set of variable into another set of variable. You can cast something as integer of float, like you can cast it as integer of something. You are casting and float into an integer. Similarly, you can cast Boolean of integer 2.9, so which is nothing but this is 2, and then Boolean of 2 is nothing but again true. So here you are typecasting a float into an integer, and again integer is getting converted into a float. Whereas in another words, if you want to convert a Boolean into an integer, which is nothing but 1 and a 0, and the moment you convert an integer into a float, which is nothing but you add, say for example you have 3.14 and you add 1, which is nothing but you are converting this 1 also into an float, which becomes 1.0. So you are converting a one set of variable into another set of variable for our own operations that we want to do it out downstream. So having this understanding, let's proceed to let's quickly review what are all the arithmetic operators are there and what are all the comparison operators are there before jumping into our demo session. Quickly, I think addition 100 plus 100, which is 200. I think this is what we would have been learning from our elementary school onwards. 20 minus 10, which is very intuitive, right? If it is a multiplication, you do something like an 5 into 5, which becomes 25. Division 5 by 2, which is nothing but 2.5. So these are all basic things. Here, when we want to extract something separately, say for example, when you want to divide 5 and 2, but you want to extract only remove the decimal and only extract what is before the decimals, you can use something like an truncating one, which is when you use 2 slashes, you only extract 2, which is nothing but This can be written as integer of 2.5 as well. I'm just what we have learned in the previous slide, I'm just showcasing it here. But both operations are different. Here we are trying to convert an float into an integer, but however here we want to extract an integer whatever before the decimal after doing the division. Whereas modulus, which is called as a remainder, when we want to extract a remainder 2.5, which is nothing but 2 into 2 4 plus 1, this 1 is a remainder, so this is what we are trying to extract a remainder. How this is useful, where this is useful, we will be discussing maybe in future seasons, not in season 1. 5 to the power of 2, anything that is exponential we can use simply 2 stars. Also, when we learn about NumPy, especially I think assume it out season 3 or season 4, we will also discussing something about power operations in a different format using NumPy. But yeah, moreover, I hope this is an basic arithmetic operations. I think learning these operations and doing some basic programming, I think this would be much more efficient and far more sufficient. And coming to our comparisons is nothing but you have something called an variable 1 and variable 2. You want to compare several things. Like here there are several comparisons: equal to, not equal to, less than, greater than, less than or equal to, greater than or equal to, something like that. So is 5 is equal to 5? Of course true. Is 5 is not equal to 5? Of course they both are same, right? So it is output as false. Is 4 less than 5? Of course it is true. Is 5 greater than or equal to 5? Of course it is true. Is 4 less than or equal to 5? Of course it is true. Is 5 greater than 4? Of course it is true. So this is how you can use comparison operators and get your result as a Boolean, which we have discussed in our slide number 1. So this is where we will end for this slides discussions for today's episodes, and quickly jump into our demo. But however, before jumping to our demo, as a norm, let's go through our homework. So here, as this week's homework, I'm asking to create a function. How to create a function? Just go to our slides of week 1, and then you will be able to understand how to create slides. And I think basic arithmetic operations, you would, once you try it on your own, like you create 2 variables like variable 1 and variable 2, I think you can create it in a very simple manner. So what I'm expecting here is that you pass 2 variables, the output, okay, of this function, arithmetic and operations function, should be able to print all these arithmetic operations. Very simple. Okay, don't worry that we have not discussed functions so far, but just go through week 1 and try it out. I think this will be much more useful when we go to our functions episode, and when we combine all these things, I think you will appreciate much more in a better way. Coming to our question 2, here I have given some code. Identify what is right and what is wrong and why it is wrong. Understanding why it is wrong improves our learning. It's not just knowing wrong and googling it out, but why it is wrong improves our learning route. So just I would like to know why it is wrong here. So that's more about homework. And before going to demo, there is one more thing just I would like to discuss for a couple of minutes or less than a minute. So I have written a new blog. Does data scientists need to learn programming? Which is much more necessity. I felt it out, especially when Devin has been declared as an AI programming or an replacement for an programming. But just go through this quick blog where I have just mentioned what are the steps for a coding activity, like what to code, how to code. After doing all those things, we have to test the code, and of course we have to code everything in a one box that is called a limitations, which is nothing but a physical limitations that we have it. Go through this block and you will see that we can never fully automate an end-to-end coding operation. It is always an AI assisted. Like chat, you can use like earlier. We earlier used to use Google. After that, Stack Overflow, because Stack Overflow has a ready-made answers rather than Google. After Stack Overflow, right now maybe people are using ChatGPT along with Stack Overflow. Similarly, these tools will become an assisted to a programmer such that his time to produce a result will be much more faster. Say, for example, we don't have these assistants, maybe resolving that might require a lot of time. Having these assisted tools, we can do it in a very quick time, just like an instant gratification. Okay, cool. Let's jump into our demo. See you there. Welcome back to our demo sessions. Here we will go through whatever we have learned so far in our slides. We'll try to replicate those things, but in a mix and a match fashion, where we will try to mix everything like booleans, integers, typecasting, floats, arithmetic operations, and comparison operators. Let's declare num1 variable as 100. Similarly, let's declare num2 variable as true. Let's try to add both of them right now, which we have seen it out earlier. Print num1 plus num2. So here it has printed as 101 because true it has interpreted as 1. Now let's create one more variable num3 as bool as 100. The moment you typecasted 100, which is nothing but an integer, into a boolean, it's stored as true. Very simple. What we'll do is that let's create num4 and we'll let us typecast this boolean into a float, which has become 1 because true is nothing but 1. Now let's add num3, num4, which is nothing but a float variable, along with number 1. Let's see what it prints. Print num4 plus number 1. Here you can see that it prints as a floating variable. Here earlier both of them are integers because assume it out, okay, it has typecasted a boolean into an integer. When we added 100 plus 1 as an integer, it has given us a 101. However, when we typecasted just a boolean into an float and we added an larger integer as well, it becomes a floating addition and it has typecasted into a float, which is nothing but 101.0. Now let's quickly do some basic other arithmetic operations which we have not seen in slides. We will raise it to some power. Say for example, let's print 2 to the power of 5. Here it has printed as 32 because 2 to the power of 5, like 2 into 2 into 2 into 2 5 times becomes 32. Now let's store this variable. We are doing an power operations like exponential operations and storing that into a variable x. So directly x has been assigned a value of 32 and it has not been assigned a operations of 2 in 2 to the power of 5 because as a way, at a backend Python calculates this and creates a variable 32 and assigns that to x. It's very simple. We have learned in our previous episode because it's a placeholder. Now to this 32, let's do some division operators. Let's create one more y and with a 3. Here we can see that variable y got created and has an number 3. Now let's do an basic division operations, which is x by y. Here you can see 10.66666. Now this is a very large decimal. People might be asking, how to I round it off maybe to 3 decimals. Let's do that. Print. Now for rounding off, there is something called a function called round. And here x comma y, which is nothing but my operations. And I want to round it off to, say, for example, 2 decimals. I'll round it off to 2 decimals. Here you can see that instead of 10.666666, it is stored as printed as 10.67 because I rounded off to 2 decimals here. So this rounding is very much useful when we are actually showcasing those numbers for an other person. For internal operations, it doesn't mind because the program can calculate the decimals, but only for readability it matters a lot. Now let's do some remainder operations. What is a remainder of 32 upon 3? Quickly calculate. Or you want to see what it been given by the computer, so which is 2. How it comes? 3 into 1030 plus 2, which becomes 32. So this 2 is nothing but remainder because it cannot be divided by 3. So that's what it is. Now quickly do our comparison operators, which we have seen it on our last slide, which gives your Boolean variable. Say for example, let me assign that piece to here. Say let me create a variable and let me do a comparison whether 100 is greater than 10. So the moment I do a comparison of 100 is greater than 10, which is of course it is a true, and assigning that to a variable var, this variable has been created and has been assigned a Boolean value of true. So when you do a comparisons, okay, the output of your comparison becomes your Boolean, which is highly useful when we are doing control, like if loop, when we compare. Okay, if true, do this. If false, do this. When we do this if logics, this becomes highly useful for us. Similarly, let's quickly do some more couple of comparison operators, like variable 1, okay, 100. Sorry, here let us create one more. Since I have created here, it has interpreted as 100 here immediately. Let me create this as variable 2, and 100 is 100 greater than 1000. Yes, of course, like 100 is less than 1000, so it's given as variable 1 as true, and variable 2, which I have changed it out here, okay, it also been assigned as a true here. Now what we will do is that we will try to do an AND operation that we have seen it out here. Now what happens if I do true or false? Let us print this. Okay, sorry, it has to be a capital T, right, and capital false, so it's very sensitive. So if it is a true or false, the output is given as a true because it's an OR gate kind of a thing, like 1 or 0, it is 1. The moment we do 1 and false, this becomes false. Instead of true here, we have learned, okay, here in variable 1 and variable 2, the variable 1 and variable 2 is output of an comparison operators, which is becomes a boolean, you can also use these things. So instead of here, say for example, you can use var1 and var2. So what does it mean is that either this and this, if both these conditions are met, what is it? It is true. If either of these conditions are met, it is an OR. So in English, you can call that in that fashion. So here, this is the basic things. I think this slides and this quick demo cars and in and out and complete list of things that we have discussed on the slides. See you next week. Stay tuned. If you like it, please give a thumbs up. Please subscribe